All right, what we're going to be talking tonight is percent error. And percent error is basically just a device that scientists use, or a calculation that scientists or chemistry students in this case helps them determine how accurate a measurement is. And what you're doing is basically comparing your measurements compared to the accepted values of the scientific community. And what you do is through this simple calculation, you can determine how many mistakes you kind of made. So if you have let's say after the calculation, you get a 5% error. What that means is that actually you didn't do that many mistakes. But if you got a 95% error, you should probably do the lab again because there were a lot of mistakes, meaning that your data does not compare well, I guess, to the accepted values of the scientific community. So if that were to happen, you'd probably want to do the lab again. All right, so what is this formula? Basically, percent error, very basic calculation, is you take your measured one, the one that data that you took in the lab, and you subtract it from the accepted value that is done by the community. Because this is on top and is the numerator, you do this numerator part first. Then what you're going to do is either press enter or use parentheses for the measured minus the accepted for the numerator, and divide by the accepted number, which is once again the one that is accepted throughout the scientific community as being an accurate number. After doing that, notice that there are these lovely absolute values. So what does that mean? It means that no matter what number you get, you will always end up with a positive number for your percent error. So if you ever see a percent error with a negative number, it is wrong. And the reason why is because you always take the absolute value of the whole equation. And because of that, it actually really doesn't matter much if you take accepted minus measured or measured minus accepted. The key is that you have to divide by the accepted number, not the measured number. And all you do with that decimal is you multiply by 100%. So let's actually do a problem. So the first example talks about how when in a lab, what you got was 10.2 meters per second squared for the acceleration of an object. But when you look at any scientific book, it says that the accepted value is 9.8 meters per second squared for the measurement or the acceleration of gravity. So this is your accepted one because that's what the scientific community said, whereas this is what you measured it as, so that would be your measured. So what you're going to do is your percent error is going to be 10.2 minus 9.8. Take the absolute value of that, and you get 0.4. Okay, and the units will actually cancel each other, because when you do 10.2 meters per second squared minus 9.8 meters per second squared, you get 0.4 meters per second squared. But remember, you are going to be dividing it by the accepted value, which is 9.8 meters per second squared. I'll put it here, but so we're going to be dividing it by the 9.8 meters per second squared. And when you look at this, the units up here will cancel out, so you'll be left with no units. So when you take 0.4 divided by 9.8, and then you multiply that by your 100, you end up rounding it with the 1 sig fig to 4%.